Hey guys, in this video we're going to be doing a quick introduction to limits. So we have this function f of x over here and it's x squared minus 4 all over x minus 2, and we have the table and the graph on the right. So right off the bat we see that our y values for x equals 2 are missing from the table and the graph. So in the table we just have an empty box, and then from the graph, we see a open circle, and that is really a hole in our graph, in our function. So what is going on? So let's just plug into and see, try to identify what's happening. So so I'm going to replace x with 2 squared minus 4 all over 2 minus 2. And I get 0 over 0. Well, that's undefined. That means, we don't have a number there for x equals 2. But how does a graph behave as we get closer to our input of 2? And that is really what a limit is. How does our function behave as we're approaching this input of 2 in this case? So the limit as x approaches 2 from the negative side. So we're really testing what is going on from the negative side and the positive side. So let's go ahead and test it. So from the negative side, as I'm coming from the left-hand side to this hole in the graph, I see that my y values are trying to approach positive 4. And from the positive side, as I get closer and closer and closer to x equals 2 to this hole over here, I see that my y values are also approaching 4. Since my number from the left-handed side and the right-handed side of the graphs, the negative and positive side of the graphs, are approaching the same number, I know that the limit exists. So, therefore, the limit as x approaches 2 of the function f of x. Now, I could write the whole thing. I could write x squared minus 4 all over x minus 2 equals 4. Or I could simply write f of x. And that's because it's already defined over here. I already know that this whole thing equals f of x. So, no need to write it out again since it's already defined. And this is your limit for this function. Let's look at another example. We have g of x over here. And we're trying to find the limit as x approaches negative 2. So let's confirm something real quick. We see this point over here. This is going to be our value for g of negative 2. So g of negative 2 is going to be 2, this point right here. But that's not our limit. Remember, our limit is how the function behaves as we get closer and closer to this x value from both sides of the graph. So from the negative side of the graph, as I get closer and closer to this hole over here, I see that my y values are approaching positive 1. For the positive side, the right-handed side of the graph or the function, I see that my y values are also approaching 1. Since the negative side and the positive side are reaching or approaching the same y value, I know the limit exists. So I'm going to write limit as x approaches negative 2 of g of x equals positive 1. So that is my limit for this function. Let's look at our last example. And right here, it's asking us, what is the limit as x approaches 0 for the function sine of 1 over x? So we have this oscillating function over here. That's a key word, oscillating. So oscillating means that it keeps bouncing up and down. Oscillating function. So it's going from 1 back to negative 1, 1 to negative 1, and it keeps going. The closer and closer you zoom into this graph, you'll see that these oscillations, it just keeps bouncing back and forth between 1 and negative 1. So in this case, the limit as x approaches 0 of sine of 1 over x is going to be d and e because it's oscillating at that point. And again, D and E stands for does not exist. does not exist. So that is what D&E stands for.